So in this video, we are going to look at finding the slope of the tangent line using the derivative. So we said that the slope of the tangent line is the derivative at a point. And when we talk about derivative, we usually talk about it in two different ways. The one interpretation is the graphical interpretation, which is the slope of the tangent line, which is what we're doing in this video. And the other one is the physical real life application of derivative, which is the instantaneous rate of change. And we talked about that previously about the average rate of change versus the instantaneous rate of change. So to find the slope right now, we're going to use this difference quotient again. Again, we kind of developed this in the other videos, is that when we are looking at a point X and we're looking for the slope, what we do is we pick another point and we say the distance between that point and X is H, and this point we call X plus H, and then we find the slope between f of X plus H and f of X. And the goal is that we want to minimize the distance between them, because as this gets closer and closer, it will become a better approximation to the actual slope. And so we let the distance between them go to 0, which is using the concept of limit. So we're going to use this definition to help us find the slope of the tangent line. So for the example, we're going to do the slope of the tangent line of f of X equals 2x minus x squared at x equals 2. And we are going to use this definition. So let's find the parts first, and then we'll do the definition. So we need to find f of X plus H, and you can do this right away in the formula, or you can do it on the side like I am, whichever one you're more comfortable with. So I have 2, and then I replace the X with X plus H. Make sure you have parentheses. And then I have X plus H, that quantity squared. Again, I need parentheses because the squared has to go to all of it. So I need to distribute the 2, and I get 2X plus 2H. And then I need to square this. So again, squaring is multiplying it by itself. You can write it out. I did it a few times already, but I'm just going to square this. So you get X squared plus 2XH plus H squared. And then you can distribute that negative. So it's going to be minus X squared minus 2XH and minus H squared. All of those will become negative. Okay, so that's my f of X plus H. You can write it again, or you can just note f of X is my original function. And then we plug it into this formula for the derivative. Okay, and every time you do have to write the limit until you actually take the limit, which means you plug in 0 for H. So we're going to take f of X plus H, this first computation that we did. And then we are going to subtract f of X. And then it's all over H. So then from there, we are going to distribute this negative, and then we should get any term that does not have an H in it to add to 0. So this becomes minus 2x and then plus x squared. Because I'm distributing negative or multiplying by like a -1 here, which will change the sign of both of them. So now if we look and we combine our like terms, we have a 2x and a negative 2x, so those add to 0. And we have a negative x squared and an x squared, so those add to 0. And nothing else is like terms, so nothing else combines. So I have 2h minus 2xh minus h squared all over h. And then I can divide each term in the numerator by the h in the denominator. Okay, since all of them are over h. So that gives me 2 minus 2x minus h. And now that we finally got the h out of the denominator, we no longer have that 0 in the denominator, which causes a problem. We can actually take the limit. So now I'm going to plug it in. When I plug it in, I don't need to write limit because I'm actually taking the limit. So this becomes 2 minus 2x. And that's the derivative. Now we want, when it's the slope of the tangent line, derivative at a specific point. So I'm going to go back to this problem and see what that point is. So I want it at x equals 2. And so I am going to plug in 2 for x to get the slope of that at that actually point. So I get 2 minus 4, which is -2. And so this is the slope of the tangent line at x equals 2. Okay. And we will get to where we find a shortcut for finding the derivative. So it'll be much faster to find the derivative and plug in the value. You also, if you watch other videos and see, they might plug in the 2 like right away into the formula, and that's fine as well. Just then when you simplified, you would get the slope value right away. Either way is fine. So if you have any questions, just let me know.